Hello students, for this next assignment I'm making my own video. Today we are talking about normal distributions and how they interact with what we just looked at last time, z-scores. So if you remember from the last assignment, our z-scores, we have our normal distribution, this curve here, symmetrically on the left and on the right. And then here in the middle we had our mean. And each one of these knocks is a standard deviation away. So for an example, if my mean was 10 and my standard deviation was 2, this would be 10, 12, 14, 16, 8, 6, 4. You can see we're just going down by 2 when we go to the left, we're going up by 2 when we go to the right. So how does this work in with probabilities? Well, so my z-scores, we know the z-score of the mean is 0, and then I go up 1 z-score, 2 z-scores, 3 z-scores, and I have -1, -2, -3. If you remember a few months back, we also learned something called the empirical rule, which is a great way for us to approximate the probability of an event divided up by standard deviations. And if you remember the numbers that go inside, I want you to pause the video, see if you can remember them correctly, and then compare your answers to what I write down. So maybe pause the video right now and try it for yourself. Alright, well if we remember, between 0 and 1 standard deviation had a 0.34 probability. Better yet, 0.34. It's always good to have that 0 in front. Now that was a positive 0.034, which means over here we're going to have, since it's symmetrical, another 0.34. Remember, that's the area of this region, just that region there. Same thing over here, this is just the area of this region here. So what was the area for between 1 and 2? That was 0.135. And the area between 2 and 3 is 0.025. And if you ever wanted to know the area after 3, it's going to be approximately 0.00. Technically, you can have something happen that's really far away from the mean, but the probability of that happening is really, really small. So since it's symmetrical, that means this is also going to be 0.135. And this is also going to have 0.025. And then anything all the way over here is going to be approximately 0.00. And that's the area within. Now we're going to talk about something called percentiles. The percentile is just all of the area preceding that value. So for example, the percentile of the mean, or z-score is 0, would be what? Well, we're talking about everything in this region here. Well, that's going to be 0.025 plus 0.135 plus 0.34, and that'll give us 0.500. So the percentile of our mean, so we're going to have our z's up here. Oh, that goes away. These will be my z's. And below my z's, I'm going to put my p's. So the probability of our p, for the probability of an event with a z-score of -3 is we go -3 and we add up all of the values less than it. So that would be 0, and then we're not going to add anything else. So the percentile for -3 z-score, let's do this in purple, P for purple, and percentile. This is going to be 0.000. So now the probability for having, or the percentile for a z-score of 2 is we go here and we just grab everything to the left. So that's going to be 0.000 plus 0.025, which is just 0.025. So to find the percentile for z-score of -1, we would do 0.135 plus 0.025 plus 0.00. And that's going to give us 0.16. I'll write that a little bit neater. 0.16. So the percentile for a z-score of 0, we would add up 0.34 plus 0.135 plus 0.205 plus 0.025 plus 0.000. And that's going to give you 0.5. And we found that before. Now the cool part is, if you notice a pattern, all we are doing to finding our new percentiles is we take this value from before and we add it to the next component. So to get my next percentile, all I had to do was 0 plus 0.25 and I got this value, 0.025. To get my 0.16, all I had to do was take the preceding percentile, 0.025, and add in the next area. So that's 0.025 plus 0.135. Now give me 0.16. We can use that method to save us some time. So we want to find the percentile for a z-score of 1. We would do 0.5 plus 0.34. And that's going to give you 0.84. Now to find a percentile for 2, we just add 0.084 plus 0.135. And that'll give us a percentile of 0.975. And then lastly, when we get to 3, to find the percentile for 3, we just add 0.0975 plus 0.025, and you'll get 1.00. Now I left that little space there because actually, remember we said it's possible, however unlikely it is possible for something to happen all the way out here. You know, some people are remarkable and they defy the probabilities. So we don't want to say it is 1.00. We want to use a tilde symbol, that's just like a little squiggle, approximately 1.00. And the same thing goes for all the way back here in our original 0.00. It's possible for someone to be remarkably good. It's also possible for someone to be remarkably bad. So this isn't going to be exactly 0. It's going to be approximately 0.000. Maybe there's like 0.0000 and then like a 6. Who knows? So these are your percentiles for your normal distribution. So why is this important? Well, this provides us with a nice, easy way to do faster calculations. Suppose I wanted to find the probability of an event with a z-score between 0 and 1. Well, we know that the probability of an event happening between 0 and 1, it could be anything. The z-score could be 0.5, it could be 0.86, 0.32, but no matter what it happens, we know that the z-score is going to happen somewhere. We'll use a fancy pen for this. It's going to happen somewhere in this area. So that means the probability of a z-score, of an event happening with z-score between 0 and 1 would be this area here, 0.34. Now they're not always that easy. Sometimes it's a little more complex. We typically say something like this. Find the probability of an event occurring within one z-score of the mean. In fact, they probably wouldn't even say z-score, they might say standard deviation. So when they're saying within 1, that means we could be 1 over or we could be 1 below. So we want this entire area now. So our probability would be between -1 and 1, which is 0.34 plus 0.34, which would be 0.68. Let's just do one more, and then that'll be the end of the video. Suppose I want you to find the probability of an event within 2 standard deviations. That's just me asking you, what's the probability? So we're going to be either -2, we're going to be under 2 or over 2. So that would equal all of this. So that's going to be 0.135 plus 0.34 plus 0.34 plus 0.135. Add all this together, get 0.95. This is going to be a very important number that shows up when we talk about something called confidence intervals in a couple of days. So with this video, you should be able to do your assignments. Hope you guys are having a safe quarantine. Please email me with any questions. Thank you.